Okay, so now we're being asked to write the standard form of a hyperbola given different properties of that hyperbola rather than if they were to give us the actual equation. The things you absolutely have to write the equation for a hyperbola, you need to know the center, you need to know A, and you need to know B. Okay, so let's draw a picture of what we have at this point. Okay, we have a center at 1, 4. Let's put that on there. We have a vertex at 110. And we have a focus point at 114. Now notice, as opposed to our ellipses that we did before, the focus point is outside of the vertex. Okay, it's past the vertex. With an ellipse, it was in between the vertex and the center. This time it's past it. Okay, so here are our points. Now we can see that this is going to be a vertical hyperbola because the points are lined up vertically. Okay, and if we go from there, we can find some of the parts we need. We have the center, so that's a good start. So our center is going to help us start to write this equation. We know it's going to equal 1 every time. For our center, now this is vertical, so our y comes first in our equation and our x comes second. Okay, so we'll have y, and our center is at 1, 4. So we'd have y minus 4, since 4 is the y coordinate of our center, minus x minus 1, because 1 is the x coordinate of our center. Okay, now we need to know what goes in the bottom here. That would be our a squared and our b squared. Okay, so we need to know what a and b are. Well, we can see that b is the vertical distance from the center to the vertex. So this is my distance b. Okay, so how far is it from 4 to 10? It's a distance of 6. So under here, my b squared is going to be 6 squared. My a squared goes under the x. I need to find a. A would be the horizontal distance that helps us form our asymptotes to draw the curves of a hyperbola. And what we're going to use for that is we're going to use this formula down here. For hyperbolas, notice it's different than the ellipses. Ellipse, we did a squared minus b squared. Hyperbola, c is the square root of a squared plus b squared. We can see from our graph that c, which is the distance from the center to the focus point, would be the distance from 4 to 14 up there. So it's a distance of 10. So we know that c is equal to the square root of a squared plus b squared. We know that c is 10. We don't know a, but we do know that b is 6. Okay, so we have 10 equals the square root of a squared plus 36. Go ahead and square both sides. We get 100 is equal to a squared plus 36, and now let's solve for a. And that will finish up our problem. So we subtract 36 from both sides and get a squared equals 64. To get rid of the squared, we take the square root of both sides, and we get that a is equal to 8. So that goes in my formula right there. AB squared is 8 squared, or 64. So in final simplified terms, the standard form of this equation would be y minus 4 squared over 36 minus x minus 1 squared over 64 is equal to 1. That is the standard form of that equation. We'll do one more, one going the opposite direction. I use the same center so that you could kind of see how you can tell the difference whether it's a vertical or horizontal. Okay, so for this problem, we were given a center of 1, 4, just like our last one. But this time our vertex is at negative 3, 4. And our focus is at negative 4, 4. Okay, so now you can see they're lined up horizontally, which tells me I have a horizontal hyperbola. So it's going to look, our standard form of the equation will look like that. We need those same things. We need the center. We need A, and we need to know B in order to write the standard form of the equation. This is a horizontal hyperbola, so my x I know is going to come first, and my y I know will come second as far as writing down the formula. I know that my center is at 1, 4, so x minus 1 and y minus 4. Now I need to find A and B. Well, A is the horizontal distance. Okay, notice our last one was vertical, so we got B by going from the center to the vertex. This is horizontal, so this is going to give us A when we go from the center to the vertex. So how far is it from our center 1, 4 to our vertex negative 3, 4? Or how far from 1 to negative 3? Well, it's a distance of 4. So that tells me our A is 4. So right here, I have A squared underneath, or 4 squared. B, I don't have here. B would be the vertical distance here that forms my asymptotes and helps me draw my curve. But what I'm going to use to find it is the value C, because I can tell what C is. It's the distance from the center to the focus point, so the distance from 1, 4 to negative 4, 4. And that would be a distance of 5 to get from 1 to negative 4. So I know, again, C is equal to the square root of A squared plus B squared. I know that C is 5. I know that A is 4. And I'm going to use that to solve for B. So I get 5 equals the square root of 16 plus B squared. I would square both sides to remove the radical, and I get 25 equals 16 plus B squared. Subtract 16 from both sides, and I'm left with 9. So I know 9 is equal to B squared. If I take the square root of both sides, I find that B is 3. And I can now finish the standard form of my equation. It is going to be x minus 1 squared over 16 minus y minus 4 squared over 9 equals 1. So there you go.